Welcome back, session 3, chapter 1, real numbers. Okay, during the last session, what we learned? Let's recall. Do you remember that? What it means? Most important lesson learned yesterday. Yesterday here means in the previous session. Can we recall? Okay. Or let's see what we learned so far. Concept of HCF, concept of LCM, correct? Then viewing HCF from angle 40 degree and viewing HCF from angle 77 degree. Well, and its application. In one problem we used this trick and also the application here. Correct? What else we learned? Well, we learned LCM. Today we are going to recall that concept and then method of finding LCM. Yeah, of course, we learned also to find HCF, method of finding HCF. This is what we learned. Prime factorization method, if you remember, the fundamental theorem of arithmetic, correct? By that method we find HCF. Today we'll recall the concept of LCM and the method to find LCM. Then viewing LCM from angle 40 degree, viewing LCM from angle 77 degree. Then its application. Today we are going to also see Euclid's algorithm and how we can use Euclid's algorithm to represent integers differently. Okay? So let's see the concept of LCM first, correct? Okay. Let's see first the concept of LCM. Let's take two numbers, 12 and 18. What are the multiples of 12? Do you remember? Table of 12. What is 12 ones are? 12, 12 twos are 24, 3s are 36, next 48, next 60, next 72, next 84, next 96, next 108, and so on. Do you remember? Multiples of any number is always infinite. Now let's see the multiples of 18. What is the first multiple of 18? The number itself. Next, 18 twos are 36, 18 threes are 54, 18 fours are 72, next 90, next 108, next 126, next 144, and so on. It also has infinite multiples. So we got multiples of 12, we got multiples of 18. Now let's find out the multiples of common multiples, Let's find out the common multiples. Common multiples of 12 and 18. Which are they? Let's find out. The first, this is larger number, so let's see. 18, it's not common. 36, yes. Then 54, no. 72, yes. Next, 90, no. 108, yes. See, children, it's forming a pattern. Leave one and then you get common. Leave one and then you get common. Okay, the larger number of the two is 18. So you check with that. Okay, so 36, 72, 108, and so on. You get infinite common multiples as well. Acha. Now what is the least common multiple? Yeah, smallest common multiple. Okay, least common multiple. And that is what, children? The least one is 36. So what is the smallest common multiple? Yeah, least common multiple of 12 and 18? 36. Children, okay, fine. Which are the common multiples? Least common multiple is 36. Which are the common multiples? The first one is 36. Then you get multiples of 36. 36 ones are 36. 36 twos are 72. 36 threes are 108. So once you get the least common multiples of 12 and 18, you can get all common multiples of 12 and 18. Did you get my point? Good. Okay. Now let's see how to find LCM. That is the least common multiple. And just now we have seen, if we know the multiple of any two numbers, common multiple, least common multiple, then we can find all the common multiples. Well, let's find out the LCM of 12 and 18. This method is called method of division. Method of division, or it is prime factorization method. Prime factorization method. All right, children. The two numbers are 12 and 18. Two numbers are 12 and 18. How to find the least common multiple? How to find LCM of these two numbers? Do we have to find their prime factors separately? The method is prime factorization. No. We will find the prime factors of 12 and 18 simultaneously, same time. So what we'll do? We'll write 12, comma, the next number 18 and draw this two line. We'll go for factorization of both together. Is there any number which is exactly divisible by 2? Yes, both are divisible by 2. Yeah, put 2. Both are divisible. 2 6 are. 2 9s are. Correct. Now the numbers are 6 and 9. Is any of the two numbers divisible by 2? Yes, 6 is divisible. 9 is not. Anyway, 6 is divisible. So I'll put 2 here. 2 3s are 6. 9 is not divisible by 2. So it will remain as it is. Well, now you got 3 and 9. Is any of those two numbers divisible by 2? No. Neither 3 nor 9 is divisible by 2. Then check the next prime number after 2, and that is 3. Is any of these two numbers divisible by 3? If you observe, both are divisible by 3. So 3 ones are 3. 3 threes are 9. Well, now you got 1 and 3. Is any of these two numbers divisible by 3? Yes, the second number. So write 3. 1 is not divisible, so it remains as it is. And 3 ones are. Till you get ones, you have to find the factors. Thus, LCM. I'll use capital everywhere. Okay? LCM of 12 and 18 is equal to, children, write all product of all these prime factors. 2 into 2 into 3 into 3. 2 into 2 into 3 into 3. Well, you may select pairs. You can select any pair, children. 2 twos are 3 threes are 9. And what is 4 nines are? 36. So what is the LCM? 36. I was talking about choosing any, yeah, it was convenient, 4 into 9. But you can choose this also. 2 threes are 6. So these are remaining. 2 threes are 6. 6 6 are 36. So while multiplying, selection of pair of prime factors is your choice. And the choice should be such that ultimately it becomes convenient for you to find the final product. It is 36. As we proceed further, we'll see situations where selection of these pairs of prime factors is very important in finding the multiplication. Okay? Try as much as you can do it orally. Fine? So what is the LCM of 12 and 18? 36. Hey children, you got LCM of 12 and 18, 36. That is the least common multiple. But what about the other common multiples? Well, the other common multiples of this. The first one, the smallest one is 36. Next, 36 twos are 72. 36 threes are 108. 36 fours are 144. And so on. These are all common multiples of 12 and 18. And the least one is 36. Here, what I want you to notice is, once you get the least common multiple of two numbers, you can get all common multiples. Okay? Well, however, you have to find here LCM. So LCM is 36. Okay? So what is the LCM? 36. Of which two numbers? 12 and 18. By which method you found the LCM? It's called division method or prime factorization method. What did you observe? While finding LCM by division method, both the numbers are taken together and factors, their factors, prime factors are obtained simultaneously. Is that clear? Fine. Can we take one more example? Okay. Question. Obtain LCM of 25 and 35. Correct? Which method you are going to employ here to find the LCM? Correct. Division method. Alright. What is the division method? 25 and 35. These are the two numbers. We are going to find its prime factors simultaneously. Now I am going to save some energy. I am not going to draw those horizontal lines. Not only saving energy, also the ink, right? Well, is any number divisible by 2? Very interesting. Is any of the two number divisible by 2? None. So next number is 3. After 2, the next prime number is 3. Check. If any of these two numbers is divisible by 3, once again, none. After 3, what is the next prime number? 5. Is any of these two numbers divisible by 5? Yes, both are divisible. You can see that. So put 5. 5 5s, comma. 5 7s are. So two new numbers you got are 5 and 7. Check whether any of the two numbers is divisible by 5. Yes, 5 is divisible, 7 is not. So 7 will remain as it is. 5. 5 1s are. And 7 will remain as it is. Alright. Now two new numbers you got is 1 and 7. Is any number divisible by 5? We'll check. We'll continue with 5. We'll check. Correct? Is any of the two numbers divisible by 5? Answer is no. Then after 5, what is the next prime number? Good. 7. Is any of the number divisible by 7? Yes. Second number. So 7. 1 is not divisible, so it remains as it is. And 7 1s are 7. You got 1s. Thus, LCM of 25 and 35 is equal to the product of all these prime factors. 5 into 5 into 7. What is convenient? Any. Okay, I'll take this. 35 into 5. 5 5s are 25, 2 is carried. 5 3s are 15 and 2 75. So 175 is the LCM of 25 and 35. Children, did you get that? Okay. Sure. Now, visualization of LCM. Visualization of LCM from 40-degree angle. ये क्या है? Let's see. Say children, 36 is the LCM that you got of 12. 36 is the LCM that you got of 12 and 18. In the previous case, first example, 36 is the LCM of 12 and 18. So let me divide 36 both by 12 and 18. 12 threes are 36, remainder is 0. 18 twos are 36, the remainder is 0. Now let me use Euclid's algorithm. We had seen that earlier. The dividend 36 is divisor 12 into quotient 3 plus the remainder 0. Dividend 36 is equal to divisor 18 into quotient 2 plus remainder 0. So this means 36 is equal to 12 into 3 plus 0 is gone. 36 is equal to 18 into 2. Children, look here, something is same. And what is that? 36. And these two are co-primes. The GCD, HCF of 2 and 3 is 1. So they are co-primes. In this situation, look, 36 is LCM of 12 and 18. Isn't it? 36 is LCM of 12 and 13. So from this situation, from this picture, from this condition, what you can say? 36 is LCM of 12 and 18. ये circumstances में आप 36 को 12 और 18 का LCM कह सकते हैं. Correct? Did you observe that? Let's have a little bit. Okay, this 36, I call it A. 12, I call it X into 3, that is somewhat B. 36, this is repeating, so I'll repeat here A. This is different, Y. This is different, C. What do you observe? The same number A is represented in product form. So A is what? LCM of X. A is multiple of X. A is multiple of B. A is multiple of Y, A is multiple of C. But A is, when these are prime, when these are co-prime, when B and C are co-prime, A is least common multiple of, A is equal to LCM of X and Y. Would you like to see one more? X is equal to M into K. X is equal to N into L. What you can say in this situation? X is equal to LCM of M and N. So this concept, I have called it as visualization of LCM from 40 degree. Correct? We'll be using this concept somewhere in the word problem. Now, visualization of LCM from angle of measure 77 degree. And what is that? 77 degree. And what is that? That is the basic concept of LCM. Like we have seen, 4. What are the multiples of 4? 4, 8, 12, 16, 20, 24 and so on. Okay, let me take 6. What are the multiples of 6? 6, 12, 18, 24, 30, 36 and so on. Which is larger of the two number? 6. So let's see. Is 6 common? We'll see the factors of 6 and check whether they are present in 4. Sorry, not factors, multiples. 12 is common. Then 24 is common. Then you will have 36 common. Alright. So common multiples are 12, 24. Then you know, children, multiples of 12. Which are the multiples of 12? 12, 24, 36, 48. All these will be the common multiples. And which is the least common multiple? It is 12. You understand? This concept, it's the fundamental concept. It gives you the definition of LCM. I'm going to call visualization of LCM from 77 degree. Is that clear? That also we are going to use it word problem somewhere. Okay? Let's see the word problems now. Okay. So children, are you ready for the word problems? You can see the statement of two word problems here. But first, we'll concentrate only on the first one. Don't try to read the second one, please. Because it is on the board in front of you. You might read this. Don't read just now. You only concentrate on first one. Ready? Find the smallest number which, when divided by 12 and 18, leaves the remainder 7 in each case. Find the smallest number which, when divided by 12, the number divided by 12, and that same number divided by 18 leaves the remainder 7 in each case. Can you put that symbolically? Let's see. Solution. Divided by 12. So in the first case. Then divided by 18 in the second case. And that smallest number we do not know. It is unknown. So let's say that number is x. So x here. X here. Is that clear to you? Fine. When you divide, the remainder is going to be 7. When you divide this x by 18, the remainder is going to be 7. Remainder would be 7 in each case. Let's say this quotient is q1 and this quotient is q2. Because this is unknown, we do not know what is the quotient. Now use Euclid's algorithm. The Euclid's property. बोलिए, the dividend x is equal to divisor 12 into quotient q1 plus the remainder 7. In the second case, dividend x is equal to divisor 18 into quotient q2 plus the remainder. Correct? Hey children, you have to be careful. Please try to understand here. Well, we want only the product. Your remainder is not 0. So I am carrying those remainders plus 7 on the other side. Therefore, x minus 7 is equal to 12 into q1. Here, in second case, x minus 7. That is also x minus 7. That is 18 into q2. Are you ready to visualize LCM from angle of measure 40 degree? Sure? Let's see. See children, this is same. Yeah, it looks a little bit odd, x minus 1, x minus 1. But it is same. So it is least common multiple of 12 and 18. X minus 7 is the least common multiple of 12 and 18. Well, these are co-primes that we have seen in that example. Okay. So what you can write from here? X minus 7 is equal to LCM of 12 and 18. And what is LCM of 12 and 18? 36. Therefore, the LCM of 12 and 18 is 36. Children, you will have to find by that division method. I have written directly. You will have to find that on the side. Okay. So, therefore, x minus 7 is equal to 36. Therefore, take minus 7 on the other side. So, x is equal to 36 plus 7, which implies x is equal to 43. So, what do you got? X is equal to 43. And what is x? That least number, the smallest number, which when divided by 12 and 18 leaves the remainder 7 in each case. Is that clear? Here you can write one statement. Let x be the smallest number, पूरा लिख दो, which when divided by 12 and 18 leaves the remainder 7 in each case. Symbolic form, and then this, and the answer is 43. Is that clear to you? Children, later on in the later videos, you will see how this can be still reduced. Okay? We will not be writing all these unnecessary things. But here, conceptually, you have to understand well. That's why I have written in this form. So in the later videos, you will see how this can be modified. It can be made compact. It can be compressed so that, because in the examination, well, Time is very important. Correct? Fine. So understood this? Alright. So this first word problem is solved using the concept of visualizing LCM from angle 40 degree. Let's see the next one now. What does the statement says? There is a circular path around a spot spill. Huge spot spill, ground is there. Somewhere there is a circular path. There is a circular path. Alright? Sonia, a girl, takes 18 minutes to drive one round of the pill. Sonia, suppose this is the starting point. She moves in this direction and completes one round. She may drive a bike, she may drive a car, whatever. Alright? She drives. She's not running, she's driving. She drives, starts from here and completes one round. Sonia, she completes one round in 18 minutes. In 18 minutes. Okay, children? Why? Ravi, a boy, takes 12 minutes for the same. Same means he also starts from the starting point and completes one round in 12 minutes. So Ravi also runs in the same direction and Ravi takes 12 minutes. Ravi takes 12 minutes. Okay, I'll read from the beginning again. There is a circular path around a spot spill. Sonia takes 18 minutes to drive one round of the pill while Ravi takes 12 minutes for the same. Suppose they both start at the same point. This is the point from where they start. And in the same direction, same time. They start at the same time. Alright? And go in the same direction. After how many minutes will they meet at the starting point? वापस कब दोनों मिलेंगे? Both are standing here. Both start at the same time. But soon, who will go ahead? Who is faster? Sonia or Ravi? Yes. Ravi takes lesser minute to complete the round. So he is faster. So soon Ravi will go ahead and Sonia will be lagging behind. Correct? So when Ravi comes here and completes one round, Sonia would be behind him. Well, Ravi goes ahead, second round, Sonia would be still back. Now longer distance difference would be there. Correct? When Ravi completes third round, God knows Sonia may be completing second round. They will meet here again. But how to find that? Simple. We are going to visualize this from angle 77 degree. Visualization of LCM from angle 77 degree. And what is that, children? The basic concept of LCM. The definition of LCM. Let's find out the common factors of common multiples. First we'll write multiples of 18. 18, 36, 54, 72, then 90 and so on. Correct? Then multiples of 12. 12, 24, 36, 48, 60 and so on. Which is the least one? The bigger number is 18. So check for that. 18? No. 36? Yes. So least common multiple of 18 and 12 is 36. That means they are going to meet after 36 minutes. They are going to meet after 36 minutes. How did you get that? By finding the LCM of 12 and 18. Well, look at this concept differently. First round, second round, third round, fourth round, fifth round, sixth round, seventh round, and more. If they continue to drive, first is Sonia. she completes round after 18 minutes. So first round, when she completes first round, she has taken 18 minutes. When she completes second round, she has taken 18 plus 18, 36. Multiple of 18 starts. बोलिए 54, 72, 90, 108, 126. आगे जाएंगे तो और टाइम बढ़ेगा. All right. Now let's find Ravi. First round when he completes, it takes 12 minutes. This is minutes, huh? These are minutes. Then second round, 24 minutes. Third round, 36 minutes. Fourth round, 48 minutes. Fifth round, 60 minutes. Then 72. Then 84. Correct? Do they have common time? ये जो time है कोई common time है? बड़ा 18 है. Let's see. 36 and 36. उसके बाद आता है well, getting on out? Yes, 72 and 72. So both Sonia and Ravi will meet each other after 36 minutes for the first time. Second time they will meet after 72 minutes. Third time they will meet after 108 minutes. Children, but here nothing is mentioned. When will they meet at the starting point? So take it for granted that when will they meet for the first time. So first time they will meet after 36 minutes. And what is this 36 here? The basic concept. Visualizing LCM at angle 77 degree. 36 is LCM of 18 and 12. Correct? Children, here I would like you to notice. They might ask you, when will they meet each other for the second time? Well, you find out the LCM and then take multiples of LCM. What are the multiples of 36 now? Tell me. 36, 72, correct? 108, 144 and so on. This is first time they will be meeting. This is second time they will be meeting after 72 minutes. This is third time. This is fourth time. Well, this type of questions are asked in a competitive examination where the toughness level is quite high. Don't worry for your board examination. It's quite easy. They will just ask you when will they meet each other for the first time. Even if first time is not mentioned, I told you, you understand it as when will they meet at the first time. So they will meet each other after 36 minutes. Did you get that? So solve the word problems. See, in the first word problem we used visualization of LCM from 40 degree angle. And in the second word problem we have used visualization of LCM from 77 degree. But now how to write this? This is just understanding. Alright, लिखोगे कैसे? तो आपको ऐसे लिखना है. Solution. Alright, now that you have understood the concept, you can write. What is the main question? After how many minutes will they meet at the starting point? Suppose Sonia and Ravi will meet again at the starting point after X minutes. After X minutes. Now you know what is X. Thus, X is equal to LCM of 12 and 18. And that is 36. So you may write 36 minutes. So what is X? 36 minutes. And what is X? The time after which both will meet for the first time. How many rounds Sonia will complete after 36 minutes? Means when they meet for the first time, how many rounds Sonia will complete? The earlier table will easily give you. Go back and see. Okay. And the other method by this. What is the LCM? 36. Divide by time taken by Sonia? 18. So how many rounds Sonia will complete? 2 rounds. Alright. What is the LCM? 36. And what is the time taken by Ravi? 12 minutes. 12 ones are 12. So 3 rounds. So backward जाके देख लीजिए. Sonia has completed 2 rounds after 36 minutes, whereas Ravi has completed 3 rounds. If they ask, then you have to solve this. Okay. You were only asked when will they meet again. They will meet again after 36 minutes. That is the answer. Clear to you? Okay. So we have seen the word problems. Now we'll proceed further and see what is Euclid's algorithm. All right. Observe and understand. Observe and understand. I am taking few numbers and dividing 10, 11, 12, 13, 14, 15, 16, 17. All right. You may take hundreds of such numbers. Continue 18, 19. But divisor, I am going to choose only one number. Let me take 4. 4, 4, 4, 4. All right. 4 2s are 8, 10 minus 8, 2. 4 2s are 8, 11 minus 8, 3. 4 2s are 8, 12 minus 8 is 4. 4 2s are, sorry. 4 3s are 12 and the remainder is 0. 4 3s are 12 and the remainder is 1. 4 3s are 12 and the remainder is 2. 4 3s are 12, remainder is 3. 4 4s are 16, exactly divisible, so remainder is 0. 4 4s are 16 and the remainder is 1. What remainder do you observe here? What is the remainder when the divisor? Divisor is 4 in each case. And what do you find remainder? 0, 1, 2, 3, 0, 1, 2, 3. Keep on dividing. Every time these remainders are going to repeat and they cannot be other than 0, 1, 2 and 3. So what is the divisor here? What is the divisor? 4. And possible remainders? Possible remainders. If divisor is 4, what are the possible remainders? 0. 0 can be remainder. 1 can be remainder. 2 can be remainder. 3 can be remainder. But not 4 or more than 4. Can you tell me from that? If the divisor is 3, what are possible remainders? 0, yes. 1, yes. 2, yes. But 3 or more cannot be the remainder. Bolo, if divisor is 2, what are possible remainders? 0 and 1. Are you getting me? So, you can say divise remainder and the remainder can be greater and equal to 0 and a less than divisor. Are you getting me? यहाँ देखो ये जो रिमाइंडर है 0 है but less than 4. ये रिमाइंडर है 3k when 3 is divisor remainder है 0 but the other remainders are less than 3. When the divisor is 2, the remainder 0 है and the other remainders are less than 2. So you can say remainder is greater and equal to 0, 0 is included and less than divisor. Is that clear? Should I write that again? Any remainder is greater and equal to 0 but always less than divisor. This is one concept that you understand. Okay? चलिए आगे बढ़ते हैं. Still observe and understand, please. Okay. Let's take some numbers now. 14, 35 and 100. I have taken different numbers and divisors also I am going to take different. I take 3 here, 6 here, 9 and let me divide. This we have already seen earlier. 3 4s are 12, remainder is 2. 6 5s are 30, remainder is 5. 9 1s are 9, 1. 9 1s are 9, so final remainder is 1. Look, divisor is 9. So remainder can be anything smaller than 9 including 0. Divisor is 6. So remainder can be anything smaller than 6, including 0. It cannot be negative. Divisor is 3, so remainder can be anything between 0 and 3. 0 is included, 3 is not included. Is that clear to you? Okay. यहां से एक चीज आपको ऑब्जर्व करना है. 14 is 3 into 4 plus 2. 35, 6 into 5 plus 5. What is 3 4s are 12. 12 plus 2, 14. मिला के नहीं. What is 6 5s are 30. What is 30 plus 5? 35. मिला के नहीं. Dividend 100. 9 11s are 99 plus 1 100. मिला के नहीं. This we have seen earlier also, I have shown in one of the videos. So what is there? What is the conclusion? Dividend is equal to, this is divisor into, this is quotient plus, this is remainder. Okay children, please, I'm going to use symbols here. Q for quotient, R for remainder. Now D for divisor and D for dividend, they are same. So there will be confusion if I put D for both. So what we do, I'll use A for dividend and B for divisor, Q for quotient and R for remainder. Okay, Q for quotient and R for remainder. But for dividend A and for divisor B. And you know, dividend, this dividend inside one is always bigger than divisor. Correct? So A is greater than B. I'll put all these symbols in this equation. What is dividend? A equal to divisor B into quotient Q plus remainder R. And recall that condition for remainder. That remainder, this remainder is greater and equal to 0, but always less than divisor. This was symbolically, this equation was symbolically for the first time given by Euclid. So it came to be known as Euclid's division lemma. Euclid's division lemma. Now what is Euclid's division lemma? Try to understand. We choose two positive integers. We choose two integers A and B. है ना? हमने दो इंटीजर लिया 14 और 3. सेकंड केस में 13 और 6. थर्ड केस में 100 और 9. दो इंटीजर लिया ना पॉजिटिव. तो we get two more integers, positive integers 4 or 2 in the first case. We get two more integers 5 and 5 repeated integers in second case, and we get two more integers 11 and 9. So when we take two positive integers and divide, we get two more integers which satisfies dividend is equal to divisor into quotient plus remainder. Are you getting me? Excuse me. Alright. So that is Euclid's division lemma. What it says? Given two integers, given two positive integers. कौन से दो positive integers? A और B. Given two positive integers A and B, there exists two more positive integers, Q for quotient and R for remainder. Q for quotient and R for remainder. There exist two positive integers Q and R. Satisfying this condition, satisfying A equal to BQ plus R, where 0 less than equal to R less than B. This statement was given by Euclid and it came to be known as Euclid's division lemma. So I hope you understood what is Euclid's division lemma. I hope you understood each and every word of this statement. Okay, fine. Now, the last concept of this video, alright, or today's last concept is representation of integers using Euclid's division lemma. Of course, positive integers using Euclid's division lemma. All right. Now, what is Euclid's division lemma? A and B are two positive integers such that A is greater than B. Then this A dividend is equal to divisor into quotient plus remainder, where that remainder is greater and equal to 0 and less than B. This is equation number 1, which is Euclid's division lemma. Here I can say the value of R is between 0 and B, where 0 is included and B is not included. Okay. Now what can be chosen as divisors? Case 1. ये जो divisor है, you can take B equal to 1. That I'll take later. Case 2, you can take divisor 2. Case 3, you can take divisor 3. Divisors, you can divide by 1, you can divide by 2, you can divide by 3. So let's see. I'll start with this. This we'll see later. If B equal to 0, then your remainder would be greater and equal to 0 and less than B, matlab less than 2. Which means R equal to 0 and 1, correct? R is between 0 and 1, where 0 is included but 2 is not included. Sorry. R is between 0 and 2, where 0 is included and 2 is not included. So which numbers including 0 is between 0 and 2? 0 and 1. Clear? I'm going, okay. Case 2 में दो चीज है. In case 2, take R equal to 0, B equal to 2, B equal to 2 and R equal to 0. ये equation में डाल दो. So what you are getting? A is equal to B, that is 2 into Q plus 0. Or you can take, once again, B equal to 2, but this time you take now R equal to 1. So what is the equation? A is equal to 2Q plus 1. Correct? Yeah, plus 0. If you don't write, then also it will do A is equal to 2Q. A is equal to 2Q. I'm going to erase this. I'll do that later. Right? Alright. So what is your dividend? 2Q. Yeah, what is your dividend? 2Q plus 1. If you want, you can change that. A is equal to 2K. A is equal to 2K plus 1. You may say A is equal to 2M. And here A is equal to 2M plus 1. Here you can say A is equal to 2x. And here you can say A is equal to 2x plus 1. Anything. So any integer can be represented in this form. Any integer can be represented in this form. Let us see the justification, children. Please. Very important thing we are going to see. Okay. I'll forget about all these expressions. Let's take only Q right now. Okay. Now, take Q different values of Q. Take Q equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Q will take different values. Pick up different values of Q. Okay. And see what you are getting. Here I am writing 2Q and here I am writing 2Q plus 1. And here I am putting the value of Q. What you are taking Q as 0. So 2 into 0 and that is equal to 2. Sorry. See the mistake that I make like you. 2 zeros are 0. Okay. Again, 2 into 0, you are taking which value of Q? 0. Plus 1. That is 0 plus 1 and that you are going to get 1. Clear? Okay. Let's take second value of Q 1. So 2 into 1. Take Q equal to 1. 2 into 1 plus 1. This gives me 2 ones are 2 and 2 plus 1 3. Observe nicely. Next I am going to take 2 Okay, so 2 into q, that is 2. 2q plus 1. So 2 into q की value 2 plus 1. This gives me 2 2s are 4 and 4 plus 1 5. Take 3. Can I write directly now? 6 and 7. Take 4, 8 and 9. Hey children, observe nicely. Dear students, 2, 4, 6, 8, 0, 2, 4, 6, 8. They are all even numbers, even integers. And 1, 3, 5, 7, 9. They are all odd. Correct? So remember, this is the basic expression which shows the integer is even. Which is the basic expression? 2q. 2q means what? Multiple of 2. And every multiple of 2 is even number. Are you getting me? So please remember, 2q is the basic expression for even numbers. 2q is even, उसमें एक ऐड कर दो 2q plus 1 और even में 1 ऐड करोगे तो आपको odd मिलेगा. So 2q plus 1 is odd. See, it's representing odd numbers. And remember, this 2q plus 1 is the basic expression to show that the number is odd. The integer is odd. So 2q plus 1 represents even number. 2q represents even number and 2q plus 1 represents odd number. Got it, children? Okay. And if you take together 2q and 2q plus 1, it will give you all positive integers. It gives you all positive integers. In case of 0, you avoid this. Alright? Here you got 0. Any integer is obtained. If you take minus values here, you get minus. You will get all integers. Are you getting me? Okay. So any integer can be represented as 2q or 2q plus 1. Are you getting me? Come when you take divisor 2. Now let's take divisor 3. Case 3. Case 3. Case 1 is still pending. Case 3, we take b equal to 3. So your remainder would be greater than equal to 0 and less than 3. So remainder that can be chosen will be 0, 1 or 2. So you have 3 cases here. You have 3 cases here. 3 remainders. This time what you are going to put the value of b? B is fixed. It is only 3. Correct? But remainder either you take 0, 1 or 2. So 3 different paths you will have. A is equal to 3q plus remainder 0 for the first time. Second time, A is equal to 3 into q plus remainder 1. And third time, A is equal to 3q plus 2 plus 0. No use of writing that. So any integer can be represented as 3q, 3q plus 1 and 3q plus 2. This is one more way of representing integers. Alright. Look now. Justification. I'll take value of q and see what I get 3q, what I get 3q plus 1 and what I get 3q plus 2. Take q equal to 0. Value of q I'm taking 0. 0 3s are 0. 0 3s are 0 plus 1, 1. 0 3s are 0 plus 2, 2. Okay. Now take q equal to 1. 1 3s are 3. This part will be 3. 3 plus 1, 4. This part will be 3. 3 plus 2, 5. Take 2. Take q equal to 2. 2 3s are 6. 6 plus 1, 7. 6 plus 2, 8. Hey children, aren't you getting all integers? 0, 1, 2, 3, 4, 5, 6, 7, 8. If you proceed further, you will get more integers. So 3q, 3q plus 1 and 3q plus 2 is another way of representing positive integers. Are you getting me? Alright. Now we are back to case 1. Back to case 1. Please. Yes. So remainder would be what? Greater than equal to 0 and less than 1. So in this case, remainder will be only 0. remainder would be only 0. So that equation में take b equal to 1 and r equal to 0. So a is equal to 1 into q plus 0. So a is equal to q. Q you can take anything. 0, 1, 2, 3, 4. So any integer is represented by q. Or you can say any integer is represented by k. Any integer is represented by x. Any integer is represented by m. When you take divisor 1. Alright. Children, would you like to take case 4? Case 4. Take this b is equal to 4, divisor 4. So remainder, I am writing directly now, 0, 1, 2 and 3. Case 5, b equal to 5. So remainder will be 0, 1, 2, 3, 4. Case 6, b is equal to 6. Remainder is equal to 0, 1, 2, 3, 4, 5. Now the way I have showed you, if you can try at home, okay? And while trying, you will say, "Hey Ram, कितना लंबा काम करना है," correct? And when you go for the next, or, and you will say, "Hey Allah, how much I have to do?" And if you go further, you might say, "Oh God, oh Jesus," right? मेरा कहने का मतलब है आपको भगवान याद आ जाएगा, right? But then there is a trick. Children, please. आपको पता है पहले Q आता है. Q, correct? Sorry, हाँ. Case 4 में divisor 4 है. So you can say 4Q. और 4 remainder है. So 4 times you write OQ, OQ, OQ. Please pay attention. Divisor pi है. So you write pi Q, 5Q, 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 5Q 5 times. Divisor 6 है. So write 6Q, 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 6Q and 6Q. Right? Right? चलिए. Remainder पहले में plus 0, plus 1, plus 2, plus 3, plus 0 you may not write. पहले में plus 0, not writing. Plus 1, plus 2, plus 3, plus 4. Plus 0, plus 1, plus 2, plus 3, plus 4, plus 5. Children, you put the value of Q and check. ये चारों एक्सप्रेशन मिलके आपको सारे इंटीजर्स दे देंगे. ये केस में ये पांचों एक्सप्रेशन मिलके आपको सारे इंटीजर्स दे देंगे. In this case, all these 6 expressions together will give you all integers when you put different values of Q. That means any integer can be represented by 4Q, 4Q plus 1, 4Q plus 2, 4Q plus 3. Any integer can be represented by 5Q, 5Q plus 1, 5Q plus 2, 5Q plus 3, 5Q plus 4. Any integer can be represented by 6Q plus 6Q plus 1, 6Q plus 2, 6Q plus 3, 6Q plus 4, 6Q plus 5. First case में any integer can be represented by Q. Second case में any integer can be represented by 2Q and 2Q plus 1. And 2Q is the basic form to represent even number. And 2Q plus 1 is the basic form to represent odd number. Third case, any integer can be represented by 3Q, 3Q plus 1 and 3Q plus 2. I'll give you the table up till 10. You observe and understand at home. Okay, children? Well, very difficult. I'll give you an example to understand this well. Do you all like to have milk without adding anything into it? Sure? Nothing? Even sugar? No. Most of you will not like milk. But milk से बनाई गई product. Milk product 1, milk product 2, milk product 3, milk product 4, milk product 5, milk product 6. Once again there are choices. Okay? You may like product 1, product 5 and product 7. So you will always choose those products whenever you have to eat, whenever you have to consume. Correct? Like that, here integers, alright, is representing milk. Integers is representing milk. And the different forms are representing milk products. That is how the integers can be represented differently. Are you getting me? So that's the end of the session today. Next time we will see how to use Euclid's algorithm, your division lemma, to find HCF of two numbers. Yet another method to find HCF. And then, very important, very difficult concept. But if you have understood this well, you will understand those sums which we are going to see in the next session very easily. Thank you so much. God bless you.